Hi, my name is Trinity, and today we will be going over periodic trends. The question we're going to be doing today is the one on the top of the screen, and in this question we are going to be comparing the ionization energies of different pairs of elements. So for now, let's just look at part A. And in part A, we are going to be comparing the ionization energies of neon and fluorine and of neon and sodium. So whenever you get a question like this, the first thing you should do is pull up a periodic table and locate the elements that you're looking for. So once you pull up your periodic table, you should make a series of comparisons. So the first comparison you should make is of the outer shells or subshells of the elements. So from the periodic table, you can see that both fluorine and neon have an outer subshell of 2p. So when the outer subshells are the same, then you compare Z effective. If you remember, Z effective increases from left to right. So since neon is to the right of fluorine, neon has a larger Z effective than fluorine. Now that we've established this, let's look at the concepts that the question is referring to. There are 7 concepts in total, but for now we can just look at concept 1, which states that the magnitude of electron energy is large when Z effective is large due to imperfect shielding. And remember, a large magnitude of electron energy correlates with a large ionization energy. So since neon has a larger Z effective, it also has a larger ionization energy. Now let's do part 2, where we compare neon and sodium. Once again, the first thing we do is compare the outer shells / subshells, and we can see that neon has an outer shell of 2p, while sodium has an outer shell of 3s. And 3s is higher in energy than 2p. So now let's look at concept 6, which states that the magnitude of energies are small when the electron has entered a higher shell or subshell. And remember, a small magnitude of energy correlates with a low ionization energy. So because 3s is a higher shell, sodium has a small ionization energy. So now let's do part B. So in part B, we're comparing nitrogen and carbon. And once again, the first thing we do is compare the outer subshells, and we can see that both carbon and nitrogen have an outer 2p subshell. Since the subshells are the same, then we compare Z effective. Since nitrogen is to the right of carbon, nitrogen has a larger Z effective than carbon. And if you remember from concept 1, when Z effective is large, the magnitude of electron energy is large, and the ionization energy is large. So now let's do the next part, where we compare nitrogen and oxygen. So once again, the first thing we do is compare the outer shell / subshell, and we can see that nitrogen and oxygen both have a outer 2p subshell. So now we have to do our second comparison. And you might be tempted to compare the imperfect shielding of nitrogen and oxygen, because that's what we've been doing in the past few parts. But you have to realize that nitrogen is special because it is a group 15 element. And group 15 elements require special consideration. So to explain what I mean, let me pull up an energy diagram for nitrogen. So nitrogen's electron configuration is 1s2, 2s2, 2p3. So its energy diagram looks like this. And if you look at the 2p electrons, you will notice that all 3 electrons are spinning in the same direction. So now let's look at concept 7, which states that parallel spin electron pair energies stabilize and lower the energy. So nitrogen has a lower energy than expected because of the stabilization of parallel spins. Now let's look at the energy diagram for oxygen. And oxygen has a electron configuration of 1s2, 2s2, and 2p4. And if you look at the 2p electrons for oxygen, you can see that 2 of the 4 electrons are sharing an orbital. So now let's look at concept 5, which states that electron energy is destabilized when an electron has entered an orbital already occupied by another electron. So because of this destabilization, oxygen has a higher energy. And so since neon has a lower energy than oxygen, neon has a larger ionization energy. So the answer to this part is a combination of concept 5 and concept 7. So now let's do part C. So in part C, we will be comparing lithium and beryllium. And once again, the first thing we do is compare the outer subshells. And we can see that both lithium and beryllium have 2s as their outer subshell. So since the outer subshell is the same, then we compare Z effective. And since beryllium is to the right of lithium, beryllium has the larger Z effective. And if you look at concept 1, a large Z effective means a large magnitude of electron energy, which means a large ionization energy. So now let's do the last part where we compare beryllium and boron. So let's first compare the outer subshells, and we can see that beryllium has a 2s subshell while boron has a 2p subshell. And a 2p subshell is higher in energy than a 2s subshell. And if you look at concept 6, you will see that a high subshell relates to a small magnitude of energy, which relates to a small ionization energy. So now you're done with the problem. We didn't get to use concepts 2, 3, and 4 in this question because they had to do with size, but they are still important to know and you should be familiar with them.